So today we're going to talk about FreeNAS, and we're going to start with what features you can get in the FreeNAS storage area network. FreeNAS, a lot of the features deal with the ZFS file system, and a lot of people are new to ZFS, so we'll do a quick overview of some of the features that come with ZFS. The latest version is actually due for release today, and that's the version that we'll be talking about, and I'll highlight some of the features that are new in this latest version, 8.30. We'll then do a configuration workflow. So FreeNAS is very easy to install, but once you have it, how do you actually set it up? So we'll go through the steps for that. We'll then talk about the plugin architecture, which allows you to extend the features that come with FreeNAS and add the applications that you need. And then we have a link to additional resources. And the very last slide in this presentation has the link to the presentation itself so that you can go and get that if you want to take a look at it. So let's start with a basic introduction. What is FreeNAS? So it is open source. It's released under a 2-clause BSD license. It allows you to create network attached storage. And it's based on an embedded version of FreeBSD called NanoBSD. FreeNAS in its design is designed to be a very small embedded operating system, which gives you the features that are required in a network storage device. Those core features, you can add to those by using something known as a plugin architecture, and I'll be describing a bit of the design of that architecture. The operating system itself is designed to be separate from your storage. That means you don't install it on a disk. Instead, you can install it on a flash device or a USB stick. Before today, the production version was 8.2 release, and this is the version that introduced the plugin architecture, and it came out on July 20th of this year. 8.3.0 should be announced this afternoon, so it's going to be out today. And one of the biggest features that came with this version is the version of ZFS was upgraded. So we went from version 15 to version 28, and it adds some features which I'll talk a bit about. So the biggest features that we get is something called deduplication, RAID Z3, and the ability to remove your log device. FreeNAS has actually been around since about 2004, and the original FreeNAS was called 7 and don't want to switch to 8 can use something called NAS for free. So it uses the same graphical interface that came with the 7 series. When we look at the features that are considered to be core to the operating system, basically when you're setting up network storage, you want the ability to share data over a network. And you want clients to have easy access to that data. So there are several ways to create shares depending upon the operating systems that will be accessing your storage device. So you can create AFP shares, which are using Netatalk, which makes it easy for Mac clients to connect to the NAS. If you're in a Windows environment, or if all of your clients are using a Samba client, you can create CIF shares. And regardless of the client, you can always set up NFS shares, because every operating system has the ability to mount an NFS share. In addition to those common methods of sharing data, other possibilities are available. So you can export iSCSI targets, which basically appears to the client as a raw disk, which they format and add data to. We support SSH if your users are familiar using SCP or WinSCP. FTP is a quick and dirty way of providing access to data. And we do support secure FTP and setting up chroot environments for your users. And if you want to save your network device configurations in your network, we do support TFTP. So for example, if you want to save your Cisco configurations. In addition to providing the ability to access storage, typically you're going to want to have some sort of permission structure and have define which users have access to which data. You can manually create users and groups, but if you already have Active Directory running in your network, or if you have an LDAP server, you can import the users and permissions, and they'll be available on your NAS system. As part of your backup strategy, you can schedule replication to occur over the network, and that occurs using rsync and SSH. ZFS supports something called snapshots, which gives you basically a picture of what the file system looked like in a point in time, and you can securely replicate those, and you can automate how often they are created. ZFS also has the ability to let you know if there are problems with your disks, and the technique it uses to do that is known as a scrub, and you can automate when those scrubs occur. You can also set up link aggregation, so you can combine bandwidth on interfaces, and you can also set up failover should your system become unavailable. One of the nice features about having the OS separate from your storage disks is we do have the ability to roll back from a bad upgrade. So on the device where you install FreeNAS, it actually creates two partitions. One holds your current operating system, and when you upgrade, the new system goes into the other partition. And you'll have a simple boot manager. If you decide you don't like the new version, you just reboot and you select the other partition, and you can go back to your previous operating system. FreeNAS was designed to be accessed using an administrative GUI, which you go in through a web browser. So it's very easy to use. One of the nice features that came out in 8.2 is, in addition to that web GUI, in the GUI itself, you can click on something called shell, and you will have root access to the command line of the FreeNAS system. One of the other nice things that is about this operating system is we do have a very comprehensive user's guide that walks you through all possible screens and configurations. That user's guide is version specific. So every time we have a software release, we have a new release of the user's guide. And we publish that in HTML, PDF, EPUB, and Kindle formats. It is important, though, that if you're using FreeNAS, that you read the guide that matches your release version, or else you're going to be seeing screens that don't match what you see on your FreeNAS system. So let's talk a little bit about ZFS. So ZFS was originally designed by Sun. It is a 128-bit file system, so it can allow for a lot of storage. It was also designed to be self-healing. So when a ZFS is doing those scrubs, it uses, every time it writes to a disk block, it puts a checksum on it. And when it does a scrub, it goes through all of your disk blocks to make sure that the checksums are correct. And if a checksum is not correct, it will fix that block of data. This actually gives you an early indication if you're having problems with a disk. So one of the problems with conventional hardware RAID is you can, over time, silently write corrupt data and not know about it until later on, when it starts giving you an indication there's a problem with the disk. So you can find out early on if there's a problem, and it will try to correct it if it's still correctable. The other nice thing about ZFS is it has the ability to create snapshots. There are other file systems that create snapshots, but typically the snapshot is the same size of the file system, because it's basically a picture of the file system at that point in time. ZFS uses copy on write, so the first time you take a snapshot, it takes 0 bytes of space. As things change between that snapshot and moving forward, that's when your snapshots start to get bigger. So it's a very efficient way to keep track of file system changes. You can actually roll back to a point in time, which will actually return the file system to what all the files look like in that point of time. But typically instead, we will clone a snapshot if we need to get access to older data. So snapshots themselves are read-only, but when you clone them, you get a read-write copy. And you could actually share that, have users retrieve their old files, and then stop sharing it when they have the files that they needed. ZFS, if you've never used it before and you're used to Unix-style file systems, you're not going to create things like root and USR and var and etc. Instead, you create something called a pool, and then you have flexibility in how you decide to divide up that pool. And you use things called data sets, and a data set is a portion of the pool, but it allows you to set certain properties. So if you have an area of storage that has the type of files that would benefit from compression, you could create a data set and turn the compression property on. And compression would only occur within that data set. Deduplication, if you are storing things like ISOs, where there's going to be a lot of duplicate data, in deduplication, ZFS will go through and it will remove duplicate data and just use pointers to be able to find it throughout the file system, which can actually save a lot of storage, and it can also optimize how quickly it finds things. The problem with deduplication is the process itself is very I/O intensive and it's RAM intensive. So you don't do deduplication on a system with, say, 4 gigs of RAM. You make sure that you have a lot of RAM for the amount of data that needs to be deduplicated. And typically the data that is appropriate for deduplication will go in its own data set so that you don't have to deduplicate the whole pool, just the data that will benefit from it. The other nice thing about data sets is you can, for example, create data sets for users, and you can set quotas to make sure that they only get so much space. So there's a lot of flexibility on how you divide up your storage using ZFS. So it sort of throws out all the rules that we're used to in file systems, and it allows you to do things a little bit differently. ZFS was also designed to overcome some of the limitations in hardware RAID, and it uses its own type of RAID known as RAID Z. There are 3 types, 1, 2, and 3. And basically the number tells you how many disks you can lose without losing your data. So with RAID Z2, you can lose 2 disks. Unlike hardware RAID, there are no restrictions on where those disks can be. So it's just the number of disks that you can lose. The one thing you have to be careful with when you're using RAID Z, when a disk is bad and you replace it, you have to do something called resilvering. And depending upon the size of your disks, this can take time, and it can also add additional stress to your disks. So if storage is really important for you and you have a lot of disks, typically you won't do a RAID Z1, because if a second disk fails while the resilvering is occurring, you're going to lose data. In ZFS, as new features are added, it changes the version number. So FreeNAS up to this point has been using version 15. As of today, it's now version 28. Version 30 is the most recent version of ZFS. Unfortunately, Oracle purchased Sun before that was open sourced, which means right now the only ZFS out there that has encryption, which is what version 30 added, is the one provided by Oracle. The open source operating systems out there that use ZFS, so FreeBSD, FreeNAS, Illumos, they are working on their own ways of providing encryption. FreeNAS is going to take the route of using something called Jelly, so I have the acronym in there if you want to look it up. This is the FreeBSD framework for providing disk block encryption. And we hope to introduce that in 8.3.1, which should be out by the end of the year. So let's look at some of the stuff that's new in 8.3. So we get deduplication because we're now in version 28. Before we didn't have RAID Z3, so now you do. You can lose up to 3 disks. Removable log device is a really big deal. So in ZFS, you have something called the ZIL, your ZFS intent log, and it basically tracks your writes before they're written to disk. You can, to improve performance, put the ZIL on a dedicated device, something like an SSD. In version 15, if that SSD died, you lost your pool. So that's a really big deal. So typically you mirrored your ZIL device if you put it on a dedicated device. The nice thing in version 28, you don't have to mirror anymore. And if the device goes, the only thing you've lost is the writes that weren't flushed to disk. So you haven't lost your data. So that's a big deal for people using that. The GUI added a front end to Etsy hosts. So you can just go in and put in your host entries. So this helps a lot, for example, for SSH users, having entries in Etsy hosts. The graphing system is being improved, so we do have reporting graphs that will show you nice trends over time, your disk usage, your interface usage, your bandwidth usage. These are becoming more friendlier, so now you can actually scroll and read through certain points in time. Obviously, because we're now on based on 8.3 FreeBSD, there's new driver support, and there's also a whole bunch more features which are listed at our website. Going to take a quick look at the configuration workflow. So what do you actually do to set up your storage device? So basically there's 7 steps that you should be doing. When you first install FreeNAS and you point your web browser to it, it's going to let you right into the GUI. So it's not going to ask you for a username and password, so obviously you should go in and set that. You're then going to have to tell FreeNAS about the disks that you want to use for storage, and you have great flexibility in how you set up those disks. We'll do a couple screenshots of that. You're going to want your users to have access to storage. You're probably going to want to set permissions. So you'll either have to create that information manually, or you're going to import existing LDAP or Active Directory information. You're then going to configure the shares so the network clients can access the data. Most shares are going to be associated with a service. You're going to have to start the service. You'll want to test your configuration, and you're not going to want to forget, once everything is working, to back up your configuration. So we'll take a quick look at some of the screens we have for that. So this is the administrative GUI. So we have buttons that allow you to set up all of the features, and those are repeated down in a tree. And this one, we're setting the administrative user account. By default, a user is created for that purpose, and its only purpose is to access the web GUI, and its name is admin. Since that's a known value, you should change that to something else. And so you're going to change admin, you're going to throw in a first and last name. Then you're going to click on change password, and you're going to set a password for that. And now you'll have to know that information in order to access the FreeNAS GUI. FreeNAS is based on FreeBSD, so it's a Unix-like OS. Admin is not the same thing as root. By default, the root user is disabled. There's no password on it. It's not allowed to SSH into the system. So really the only way to do anything as root is to use the shell or to set credentials for it. And we advise users don't do that, because root shouldn't be coming in, say, by SSH to access your system. Once you've set your credentials, you're going to want to create your volume. And FreeNAS supports a lot of ways to set up your disks. So you really want to think ahead of time, how do I want to design my storage strategy? Now, if you're just setting up FreeNAS as a home user and you just have a disk, you want to store your movies or whatever, you just go in and you format that disk and you're good to go. If you're using FreeNAS in a business capacity or an enterprise capacity, you're going to want to spend some time deciding how many disks am I going to use. And ZFS, if you're looking at getting the best performance out of ZFS, actually has suggestions on how many disks to feed it at a time. And all of this is documented in our documentation. But it supports a lot of stuff. So if you already have a RAID set up using UFS or ZFS, you can just import that in. If you have disks that are already formatted with UFS, FAT, NTFS, or ext23, you can just import those in as well. But typically, you have a bunch of empty disks or disks that you want to format, so you're going to create either a UFS or a ZFS volume. A lot of the features that deal with storage are based on ZFS, but if you are on say, a home system with limited RAM, you may have to consider using UFS. We recommend don't feed ZFS less than 4 gigs of RAM. So if you're sticking it on an old system, use UFS. Once you've decided how you're going to set up your disks, if you're using ZFS, you should be planning what type of data am I going to put on these disks, and you'll create data sets that are appropriate for that. So either areas that you're going to use compression, or you want to set quotas for your users, or if you're going to be using iSCSI, how much space do you want to use for each raw disk for your iSCSI initiators. We'll take a look at that screen. So we are in storage, and we want to create a volume, so we use Volume Manager. In this one, I have a whole bunch of disks, and I've decided to use ZFS. This is creating the actual pool, so I'm feeding it my disks. So we would recommend that you don't use deduplication, especially if it's going to be a large storage area. Save that for your data sets, but it is a possibility. You're then going to go in and say, what do you want to do with those disks? And you have the flexibility of doing various types of software RAID. You can do stripes, but that's not recommended because they don't provide redundancy. If you lose a disk, you've lost all of your pool. So typically you would pick a RAID Z, or you would do mirrors, depending upon your strategy. Once you have a disk, or once you've set up a volume, it's going to be listed in the tree. So here we've created a volume called Volume 1, and then you can go in and create your data sets. Creating a data set can take all of 1 second because the only property it needs is a name, and you click OK. But typically the reason why you're creating a data set is you want to set some of the properties. So you may be setting compression, or you may be setting quotas. Or possibly this is the area that you want to use for deduplication. Once your disks are set up, you're going to manage your users in groups. So you can go in and manually create them, and it's just making a regular Unix-style user. Or you're going to import from either Active Directory or LDAP. Once your users are set up, you're going to actually start sharing your storage, and you have choices. And when you are deciding what type of share, because there's a lot of shares that are supported, you want to take a look at what type of clients, operating systems are going to be accessing the storage, and also your expectations for speed and performance, because some types of shares are faster than others. So obviously something like SSH or SFTP is going to be slower because you have the overhead of encryption. CIFS may be slower because it's single-threaded, and if you don't have a good CPU, you're going to bog it down. So you really want to have a good look. All of these, we have a chapter for each type of share in our guide, and it'll walk you through some of the considerations when you're deciding to do that. Some of these are no-brainers, so if you're in an entire Mac network, AFP is probably what you're going to use. And if you're in an Active Directory, all Windows systems, you're probably going to go for CIFS. Other than that, you probably want to take a look at their considerations. We recommend that when you're setting up shares, don't create a share on the same volume or data set. Don't make multiple shares, because you're going to end up with very confused users. So for example, if I have a data set and I share it both with AFP and CIFS, some of your Windows users may see those weird files that don't make any sense and start deleting them, which will break all of your Apple files. Or if you create an NFS share and an FTP share, NFS will lock a file for editing, but an FTP user can go in and edit at the same time and it won't recognize the lock. So you shouldn't be using multiple types of shares to the same data. When you're creating your shares, you're going to want to say which users are going to have permission to that. And you can just do everything as anonymous or guest, or you can go really complex and do it per user or per group. Once you have created your shares, you have to start the appropriate service. So we do have something called services, which lists all of the possible services. And over here, the same thing will give you the status of each service. And in FreeNAS, all services are off until you turn them on. So if you go in and create an AppleTalk share, nothing's going to happen until you turn on the AFP service. And when you create your share, a pop-up message will actually remind you you need to start this service. And when you start the service, it will change to a green on. And if you need to further configure the service, every service has a little wrench icon to access the configuration. You're going to always want to test your configuration, so do it from a client operating system. You want to make sure that users can actually get at the data they're supposed to get at, and that they can't get at the data you don't want them to get at. One of the nice things in FreeNAS, especially if you're starting a service, you can go in and check a box called Enable Console Logging, and it will tail the output of varlog messages at the bottom of your browser, so you can actually see if there's any errors when you go to start a service. And if you need further troubleshooting, you just open up Shell, and that allows you to go in and look at all of the logs and see what's happening if you're having problems. Once you're happy with everything, you want to back up your configuration. So in FreeNAS, you basically have three components. You have the OS, which you stuck on the flash device. You have your disks, which contain all of your data, and you have your configuration. The configuration is stored with the operating system, but when you do an upgrade, you're going to be overwriting that. So you always, to be on the safe side, you want to back up your configuration. And then it doesn't matter if you install a USB stick and the USB stick up and dies someday, you just insert a new USB stick and you restore your configuration. And it's like nothing ever happened. So you always have a backup. The backup is going to be stored on your desktop operating system, and you do that in settings. You just click the Save Config button. And you should do that whenever you make changes. And you can rename what it's called, so you can name the file to something that reminds you this is a set of changes that I'm making a backup to. Okay, so that's our basic overflow, how to set up your FreeNAS system. A lot of users want to extend the default features that came with FreeNAS. So a lot of people want to do a lot of multimedia stuff. And we've been surprised at what people want to stick on their storage device. People want to turn them into print servers. They want to turn them into VirtualBox servers, all kinds of stuff. The operating system itself is very small. It's only about a gig in size. And you only it only creates an area of 4 gigs. 2 gigs for your current operating system and 2 gigs for a future operating system. So there is no room to install software. When creating the design, that was done on purpose. So we have a nice embedded OS, but we created an architecture that allows you to extend that. And we're taking advantage of some of FreeBSD's features to do this. So the features that we're using are something called jails, vimage, and PBIs. Those are the 3 components of the plugin architecture. With those, it makes it very easy to install software, and it actually integrates it into the FreeNAS GUI. So it's as if it came with FreeNAS. It's just something else that you configure in the GUI. So that whole thing is called a plugins jail, and it allows you to install additional software that was packaged in something called PBIs. Currently, we have 3 PBIs available that you can download from the SourceForge website. So for Firefly, Mini DLNA, and Transmission. There's about 20 others that are currently being created and tested. And once we're happy that they work as advertised, they will be added to the official repository. The nice thing is when you install software this way, that control services icon that I showed you before, they will be added to that in the plugins tab. So anything in the core tab came with FreeNAS itself. Anything in the plugins tab means you installed it using the plugin system. So there's that separation. So let's look at those 3 components and see what exactly they are. So a jail is something that's been in FreeBSD for quite a while, probably 2000, 2001. And it is a way of providing lightweight operating system level virtualization. So jails were originally very popular with ISPs because it allows them to give each client what they think is their own operating system. And on one piece of hardware, you can create thousands of jails and it won't bog down the system. It is a very lightweight way of doing virtualization. So on the server host itself, it's lightweight. To the client, it's as if they're on a FreeBSD system. They think they have everything. A jail has its own host name, its own IP address. It has its own set of users and groups. And from a security point of view, there is a separation between it and the hosts. So again, one reason why jails were popular is if your client installed a web server in their jail and it got hacked, it doesn't affect any other jails and it doesn't affect the host system. So there is a security isolation there. The current FreeBSD implementation doesn't include something called vimage, so that's something we had to put into FreeNAS. It gives the jail its own networking stack and its own IP broadcasting, and that's needed by a lot of the multimedia applications to have that ability. What is a PBI and what's a plugin? So PBI stands for Push Button Installer. It was originally created by the PCBSD project, which creates an easy-to-use desktop based on FreeBSD. If you've ever installed FreeBSD software before, you know that you get the nice friendly command line and you work from there. What PBI does is it provides a graphical installation wrapper for any application that's been ported to FreeBSD, so you can install from the GUI. The FreeNAS implementation adds functionality to this by, in FreeNAS, typically what you're installing is server system, something that's going to listen on a port, and it will have a configuration file. So it takes the contents of that configuration file and puts it into the graphical administrative interface, and I'll show an example of that. So for example, Samba's already built in, but if you've ever played with smb.conf, you know it's a really long file. If you're playing with httpd.conf, you'll know that they're config files, so it's nice to have them in a GUI. When you add that extra functionality, adding it to the FreeNAS GUI, that's called a plugin. So let's take a look at the plugin architecture. So a plugin is considered to be one of the core services, so it shows up in your services tree. You can go in and create the settings for a plugin. So when you are deciding to play with plugins, you have to install something called the plugins jail. So it actually sets up the jail for you. We recommend that you use ZFS for your plugins jail, and that you create 2 different data sets. So one data set here I've made it on volume 1, I called it jail. That holds the FreeBSD operating system itself. And the other one down here, which I've called software, will hold all of the software that I install. If you're new to jails, a lot of people are confused, why do I need an IP address for a jail? Well, if I'm installing server software, users over the network are going to have to be able to access that service. So if I'm setting up a Bacula server, I want my backup client to be able to access that over the network. You can't just make up any IP address in there. It's going to have to be something that's reachable within your own network and not being used by another system. And you have to put the net mask associated with it. Couple of things, once you have a plugged-in jail, you can delete the whole thing from your system. If you do an upgrade and things go bad and you have to end up reinstalling FreeNAS, you can just import the plugins jail or grab it out of your configuration. And if a new plugins jail becomes available, you can upgrade it from within the GUI. Once you have installed the plugins jail, you have to start that service. And as soon as you do, you have the ability to install plugins. So they are going to show up in the plugins tab. You can download the plugins from our SourceForge website. And in this example, I've installed all 3 of the available plugins. This will show you what's installed, what the version is. It will tell you if that service is currently running and give you the ability to start it. You can update that, and if you don't want it anymore, you can delete it from the system. In addition to having the control over here, it's going to actually add it as another service that's available to your FreeNAS system. And if you click on any of these, you're going to get the GUI config screen. So in this example, I've clicked on transmission. So I clicked here, and here is the GUI front end to all of the configurable things within transmission. And it does that for each of the PBIs. So that's the part that's cool. Right now, there's only 3 official PBIs. There's about 20 PBIs out there that are usable. They've only been out since July, so obviously as time goes by, there'll be more PBIs. Just because a PBI is not available, it doesn't mean that you can't install that software. Once you have the plugins jail installed, you basically have a FreeBSD system, and it works like any other FreeBSD system. So FreeBSD has something called packages and ports. So a package is pre-compiled, ready to go. A port you can compile yourself. And there's over 24,000 applications that have been ported to FreeBSD. So typically, whatever it is you want to install, you can just go in and install it by hand. We have a whole chapter on how to do this in our documentation if you've never installed software using FreeBSD before. The only disadvantage of installing software this way is you're doing everything at the command line. You have to install it from the command line, you have to find its configuration file and edit it from the command line, and you have to start the service from the command line. So it's the PBI that integrates it into the GUI. Okay, before questions, I have a whole bunch of links for you. So we do have all kinds of resources. We do have very active forums. We do have a bug tracker for creating support tickets. FreeNAS is fully localized, and we do use Poodle, where people can easily add localization for their language. We have documentation for each release. We're on IRC. We have instructional videos for those who like to watch things, and we have a whole list of support resources. And because those went by quick, there's the URL to the slides, and you can also contact me. And we have about 10 minutes for questions. Anybody have a question? Yes?
Is there one jail for all PBIs, or does each PBI get its own jail?
At this point in time, we only have the ability to create one jail. One of the things you could do is you could create data sets for each service if you wanted to. You could do it that way, but they're all going to be in the same jail. We have had requests for the ability to create multiple jails, and that's something that we'll probably do in the 9 series. Yeah. Yes? Mhm.
off. And the second question was the configuration file that you save when you make your configuration. Is that a plain text file, or is it like
It's
a zip of the conf files that are in the etc directory?
No, so everything that you do in the GUI goes into a configuration database, and it's the database that you're saving. Okay. Regarding, is there hardware that can be bundled with FreeNAS? My employer, IX Systems, who leads, right now currently leads the development of FreeNAS, started out as a hardware company that also provides support. So they will gladly sell you hardware as well as support. In addition to FreeNAS, which is the open source version, they have something called TrueNAS. TrueNAS is the same thing as the open source version, but they bundle it with the hardware. So you'll request a quote. Typically, this will be for enterprise users, so you're going to get things like Fusion I/O cards. You're going to get high-level disks. The only thing they add into the GUI that's not in FreeNAS is the hardware they sell you has IPMI built in, so there's a GUI to set up your IPMI credentials. And the only other difference is high availability. There's a GUI for that, whereas in FreeNAS you have to do it from the command line. But other than that, it's the same OS. Any other questions? Yes.
I'm old school. I first used NFS on a machine with 4 megabytes of memory. So when you say you need more than 4 gigabytes of memory,
Yep.
ZFS, I'm kind of surprised. What is it that makes it require so much?
Yeah, and that's a good question. So the OS itself, FreeNAS could get away with 256 megs of RAM. So the OS itself is very light. UFS is very light. UFS has been around forever. It's ZFS that requires the RAM, and it depends upon a lot of the features. So if you go to our docs and you search for why does ZFS use so much RAM, there's actually a nice article that explains in detail what it does. But a lot of it, so ZFS, every time it's writing some, it's doing checksums. It's always doing the copy on write thing. And it's usually a lot of functions that are RAM intensive. So if you're not under load and you're just doing light reads, light copies, we've had people use it with 2 gigs of RAM and not complain. Now, it's not going to be the fastest thing in the world, but if you're not expecting speed, ZFS can still do that. If you have a lot of simultaneous reads and writes and you have a lot of clients coming in over the network, it's going to very easily bog down unless you have the RAM to feed it. So whenever somebody says, well, my shares are really slow, first thing we ask them is how much RAM is in your system, and the second thing we tell them is throw more RAM in. It's the old adage, you can never have too much RAM. But there is an article that explains in detail everything that it's doing in the RAM. And after you read it, you have a good appreciation of what it's doing, and you go, okay, yeah, I guess RAM is the price to do that.
So a lot of home NASs that you can buy at Future Shop or
Yeah.
whatever, they're built on little ARM boxes with not much RAM, not much flash.
Yeah.
Those will never run FreeNAS.
Correct. Now, a lot of people, so the original FreeNAS, which is now called NAS for Free, had a different GUI interface, so it was PHP. We're using Django, which also bumps up the requirements a bit. And a lot of people very happily use that on older hardware, but they're using UFS. Any other questions? Yep.
Do I have to have a separate USB for each of my 3 computers at home? And then how do I connect to my 3 or 4 cloud accounts of storage?
So you really want to create a SAN instead of a NAS. If you want 3 different devices to be seen as one block of storage.
At home with 3 users.
Oh, 3 users, okay.
One is myself, my wife, and my daughter. 3 computers.
Yes.
And we all have our own cloud
Yes.
Do I have the 3 USBs, one for each computer?
No. So you have the one USB for the system that holds the disks, that will be your storage. You would probably want to create 3 different data sets and 3 shares, unless you guys are sharing the data. Otherwise, you could just do it in one. And you would need to use the plugins system to install whatever client you use to access your cloud, whatever that software is. Any more questions? Okay, thank you.